Thank you very much indeed. You have a whole pile of slides from me. I'm not going to go through them all. Why is Arm standing up in front of you talking about smart grids and core technology? Most, if not all, of the smart meters that are installed at the moment are based on Arm. We're an IP supplier based down the road in Cambridge, and we supply IP technology mainly to phone manufacturers, as you know. About half of our shipments go into phones, the other half go into industrial design. And as I say, most of the smart grid out there is based on Arm. Not just the core processor, but also the networking equipment that goes around it as well. So we are a fundamental building block to some of the technology that's going in place. And we see huge growth in this market. I just want to go through where we're seeing growth and where we see opportunities to grow, especially with our partners. So the first bit, not moving. Here we go. Electricity demand. We work very closely with a number of agencies in the US. And the striking thing we look at when we look at power is that second red bar up there, energy losses, especially the electricity losses. And our view, and has been since we started the company 20 years ago, is you should use every electron possible. We define terms of CO2 emissions per web hit, milliwatts per megahertz, really about efficiency. And I wanted to just point out some of the things that really are strikingly different these days. I carry one of these. Do you all have laptops? Yeah? I noticed a number of you had these things here, these tablets. Yeah? The processing power inside of here is roughly the same as the processing power inside of here. The processor inside of here is 10 times as power hungry as the one in here. The weight difference is significant. You've got a huge battery here, you don't here. You take my phone out, that's the same order of magnitude difference between this and your phone. Efficiencies come from designs at the core, not just from the system level efficiency. And so for us, you can use this all day, significantly less charge to charge it up, and you get much more efficient. So for us, critical that we get these sort of things happen. We want them in every consumer device. Next thing, if you look at we've done a lot of work with the Department of Energy in the US, and this is their numbers of trillions of kilowatt hours that they see. And if the red line, if they freeze efficiency where it is, you'll see that it keeps on going up to 2040. Their baseline that they want to reduce is by 17%. We think there's another 13% at least you can get out just by using smarter semiconductors. And I'll give you some examples of that. Motor control. If you can control motors significantly better, you can reduce the power needed to move that big motor by about 30 to 50%. Huge amount of opportunity there to replace the motor control from an 8-bit processor to a 32-bit. Not just the processor reduces power, the overall motor system reduces power. And we see that as fundamental to some of the green technology moving forward. The next thing that we see, and it plays very nicely into this smart grid, is not all end products are alike. My phone, as an example, can go to sleep. It wakes up the following morning when I pick it up, and it still has the same battery charge. My laptop, on the other hand, doesn't. My DTV doesn't. Zero use doesn't mean zero power in most devices. And so when we talk about smart grid, we should be looking at how to enable zero power when there's zero use. It has to be enabled as an intelligent device at the end of the smart grid. And it has to be able to monitor itself and go, you know what, I'm going to go to sleep. Whether it's connected via a cable or on a battery, it shouldn't care. And we're enabling a lot of this technology at the moment. we've talked a lot, and I've heard lots of very good speakers about smart grids. So I'm going to go on to what we're really doing here. And for ARM, we're working very closely with some of the microgrid technologies. We work very closely with the top 6 or 7 automotive manufacturers, not just on their in-car display, but on the electricity usage and distribution within in-cars as well, on the cam systems and the overall control of the car. And thirdly, we work with a lot of the connectivity devices. So we work with the 3G networks, we work with the power line technology companies, we work with the Wi-Fi technologies, and for us, helping to define those very low power, high performance networks are very critical in this, because connecting all of those devices are very powerful. The final thing that we're doing in this, I've heard this word come up in the last hour and a half a lot, is security. And we're building in now security into endpoints that you can go and do much deeper security with the customer, not just direct communication with them, but be able to have security of information flow between you and the customer. So that secure link is built in for even everything up to and including payments if you wanted to do that. So for us, it's critical that you have security built in as a core fundamental of the technology. But I also wanted to talk about the backhaul of this as well. Smart meters are wonderful, and putting more stuff over the internet is fantastic, but it's costing us a lot of money doing it. 2005, there was $25 billion alone spent on powering servers, cooling and powering them. The growth of the internet, and we're talking about growth of the internet here in broadband, means that this year there'll be about $44 billion spent on cooling and powering the internet. Now, if you want to save power and you want to save electrons, we should not just look at the smart grid in isolation as a consumer, we should also look at what the back end is as well. And to that end, we're actually taking the same technology that goes into phones and devices like this and putting it into servers. With the goal being, you should have your server running at ambient temperature the same way as you have your phone. You don't have to have power coming from Iceland to go do that. The technology is there, and we're working with the significant partners in the semiconductor industry to enable not just the client side of the smart grid, but the industrial design on the server side as well. And for us, that's really about connecting a smart grid, because once you have the back end and the front end talking to each other in a smart way, we believe that that will enable companies like yourselves to really grow and be able to use efficiently and effectively each electron that's produced. So with that, I think my 15 minutes are up. Thank you very much indeed.